This is the second video regarding multi-layer switching included in the CISCO ENCORE exam. Explain the different design principles used in enterprise network, high availability techniques such as redundancy, first hop redundancy protocols, and stateful switchover. So with first hop redundancy protocols, you have a way to have redundancy at your default gateway. So if your default gateway fails, another can take over. These protocols make use of virtual IPs and in some cases virtual MACs in order to work. These virtual IPs and virtual MACs are shared among devices. These protocols may also use object tracking. With object tracking, your protocols becomes aware of changes in the network. For instance, you have a device that has a one link and this one link fails, you might want to move the responsibility to another device that has a working one link. The available first hop redundancy protocols that you must know are the Cisco proprietary hot standby redundancy protocol, or FHRP, or the standard BRRP, or another Cisco proprietary protocol that is known as GLVP. Next topic, distributed forwarding versus centralized forwarding. If you have a chassis where only one card has a CPU capable of doing routing and switching, you will have centralized forwarding when you only have a single routing processor to do all the routing and switching chores for your chassis. Opposite to that, if you can have forwarding engines included in each line cards that you plug into chassis, each of these forwarding engines will copy forwarding tables from the main routing processor so they can work individually in order to move packets and frames. In that case, you will have distributed forwarding. Now, Ceph is a topic that is talked about in another chapter, but you must remember for the time being that if your forwarding engines that you have in your line cards are Ceph capable, they will download Ceph information from the routing processor, like the FIB or the adjacency table, and in that case you will have distributed Ceph, which is a good thing. A stateful switchover lets you have, for instance, two main cards in your chassis, which are known usually as controller cards, which the main controller card will be running as active and the other controller cards will be running as standby, in which the standby card will be constantly having a copy of the running FIB. So in the case of a failure of the active controller, the secondary controller will take over as fast as possible. A stateful switchover is an evolution of previous technologies like RPR or RPR Plus, and once you enable a stateful switchover, you can enable other features like non-stop forwarding or non-stop routing. You can configure a stateful switchover if you enter the command redundancy and then you enter the mode SSO. Here's a table that compares the first hop redundancy protocols. Remember that how your devices are named. For instance, in FHRP, your main device is known as active, and the other one are standby. In BRRP, the active default gateway is master, and the other is backup. In GLVP, you have an AVG and several AVFs, and so on. Remember how many virtual IPs, how many virtual MACs each protocol works with, how do you define the priority, how do you define the timers, how the hello packets is constructed and sent, how many groups you can have, and so on.